Almost every summer in Florida, you hear news about red tide, but what exactly is it and why is it so talked about? Red tide in Florida, which often occurs along the state's Gulf Coast, is caused by the accumulation of Karenia brevis, a type of single-celled organism called a dinoflagellate. Red tides occur around the world and are not all caused by the same species, nor are they always red. In fact, most dinoflagellates are harmless, but some, including K. brevis, produce neurotoxins that can cause respiratory problems in humans and attack the central nervous systems of fish and other wildlife. Red tide in Florida is designated as a harmful algal bloom, or HAB, due to the impacts it can have on the environment, humans, and our coastal economies. Red tides occur almost annually in the Gulf, particularly in the Tampa Bay to Charlotte Harbor region. The first scientifically documented red tide bloom in Florida dates back to 1844, predating extensive human development. Florida's red tides can appear throughout the year, though they usually peak late summer to early fall and can last from a few days to months. Red tide blooms in Florida begin 10 to 40 miles offshore in the bottom waters of the Gulf of Mexico, where K. brevis is almost always present at low and harmless concentrations. K. brevis cells that hang out at the bottom are brought to the surface by a phenomenon known as upwelling, a process in which deep, cold, and nutrient-rich water rises to the surface. K. brevis, like all algae, requires three things to grow and survive: optimal light, temperature, and nutrients, specifically nitrogen and phosphorus. Winds and ocean currents then bring the bloom inshore, where it has an impact on our coasts. In fact, these currents play the biggest role in determining which parts of our coastline will be affected. Once the bloom moves nearshore, nutrients associated with decaying red tide and fish kill biomass are among the most significant nutrient sources for blooms. So much so that red tide has been considered nearly self-sustaining. Nearshore red tide blooms can also obtain nutrients from air pollution, water releases from rivers and estuaries, and estuarine flux, or the exchange of nutrients to and from the estuary. K. brevis produces neurotoxic brevitoxins. Through inhalation, direct contact, or ingestion, these toxins, in high enough concentration, can harm and kill fish, birds, and marine mammals. Exposure to brevitoxins occur through inhalation or ingestion. People in coastal areas can experience varying degrees of eye, nose, and throat irritation. Eating contaminated shellfish can also lead to neurotoxic shellfish poisoning. However, keep in mind that store-bought seafood or seafood served in restaurants are safe to eat. Each year, red tides are estimated to cost Florida more than $20 million in tourism-related losses. The 2015-16 red tide event caused a $1.3 million sales loss to the hard clam aquaculture industry. Health costs and lost workdays associated with HABs cost the U.S. $22 million annually. Water samples are collected from over 100 locations throughout Florida on a weekly, bi-monthly, or monthly basis through partnerships with state agencies, county governments, and community members. The Florida Fish and Wildlife Conservation Commission maintains a daily sample map that shows results from the last 8 days of red tide sampling. During a harmful algae bloom event, the National Oceanic and Atmospheric Administration also issues twice-weekly forecasts using satellite imagery and other data to monitor blooms and the potential for impacts. Red tide blooms feed on excess nitrogen and phosphorus once they make their way to our coasts. These excess nutrients come from a variety of sources such as stormwater runoff, fertilizer runoff, septic tanks, and/or faulty wastewater systems. These excess nutrients play a role in the extent and duration of large bloom events. For more information on red tide, you can visit the FWC's website and the Florida Department of Health. The information in this video was provided by the National Ocean Service, Florida Sea Grant, and the Florida Fish and Wildlife Conservation Commission.